There's a moment that stops almost everyone the first time they see it. You're on the highway and a massive dump truck rolls past. You track the wheels out of habit, and then something catches your eye. An entire axle, a full row of tires just floating, spinning freely above the road, not touching anything, not doing anything, just ghosting along about 6 inches off the pavement. Your brain stalls. Is something broken? Did the suspension collapse? It looks like a physics violation. But here's what's interesting. That floating wheel isn't a flaw. It's the feature. And the reasoning behind it touches on road engineering, economics, and a surprisingly elegant solution to one of heavy transport's oldest problems. To understand it, you have to start with the road itself. Concrete and asphalt are strong, but they have a threshold. Exceed it at a single point, and you don't just drive over the surface, you fracture it. This is why weight limits exist, not just for the total load a truck carries, but specifically for how that load is distributed across each axle. The distinction matters more than most people realize. Think about walking across deep snow. In regular boots, you sink. On snowshoes, you stay on top. The weight hasn't changed, but the area absorbing it has. That's the entire logic behind what engineers call a lift axle. When a dump truck is hauling 20 tons of gravel, that load exceeds what 2 or 3 standard axles can legally bear, so the driver flips a switch. Airbags inflate inside the suspension system, pressing that dormant axle down until the tires meet the road. Suddenly, the truck has more contact points. The weight distributes across a wider footprint, pavement pressure drops, and the truck becomes road legal without shedding a single pound of cargo. But then comes the obvious question. If more wheels mean better distribution and less road damage, why ever lift them at all? The answer, almost always, is cost. Commercial truck tires are not cheap. A single one can run several $100s, and they wear based on mileage, not calendar time. Every tire pressing against the road creates what's known as rolling resistance, friction that the engine has to overcome. More tires down means more fuel burnt, more rubber worn, and more money spent. On an empty return trip, those extra axles serve no structural purpose. Lifting them is the mechanical equivalent of switching to eco mode. Immediate savings, no downside. There's also the matter of tolls. Many highways and bridges calculate fees by the number of axles in contact with the road. A lifted axle can reclassify a truck into a lower toll bracket, sometimes cutting the fee significantly. On routes driven hundreds of times a year, that adds up to a real number. And then there's the last reason, which is perhaps the most physically interesting of the three: turning. Long trucks with multiple fixed axles don't corner, they resist it. When the rear wheels are forced through a tight arc, they don't track the curve cleanly. They get dragged sideways across the asphalt in a process called scrubbing. You can sometimes hear it, a low grinding scream from the rear of the vehicle. It destroys tires, it strains the frame, and it means a fully loaded multi-axle truck essentially wants to travel in a straight line indefinitely. Any deviation from that is a negotiation. Lifting the extra axle shortens the effective wheelbase. The truck becomes more responsive, able to pivot through tight construction entrances or city intersections without grinding itself or the road to pieces. So, the next time you see a truck with a wheel hovering silently above the pavement, you're not watching a malfunction, you're watching a system make a real-time decision, balancing load laws, fuel economics, tire longevity, and geometry all at once. It's a machine that changes its own shape depending on what the moment requires. That's not a glitch. That's engineering doing exactly what it's supposed to do.